So the objective of this lesson is to basically understand the substitution, firstly integration by substitution technique. Also, what we'll go through is first the major type of question that are asked in standard level course. So these are the kinds of questions that you notice they are more of common core HL and SL questions. So before I begin up the substitution, like the one of the very basic result that comes in uh, handy is the derivative expression of, let's say, ln fx. If you're differentiating the ln of function, ln of some function, it is 1 over fx times f dash x. So the first technique that you use in substitution is that, okay, if I have got, let's say, a function in the numerator, a function in denominator, and its a derivative is in numerator, the integration of that function is straight away nothing but the ln of the function. So for example, if you see f dash x, so if you have f dash x over f of x, um, is straight away the integration of this is ln f of x plus c. Now, what example that supports this is, let's say I have got a question where it is like 2x over x squared plus 5. So that's your question number E. So whenever you have the function in denominator and its derivative, exact derivative in numerator, so the thing is that here you can see that x squared plus 5, derivative x squared plus 5 is nothing but 2x. So it's like f dash x. So it's the format is f dash x over f of x format. So the integration of this is going to be straight away ln of x squared plus 5. So here you can just write down ln of x squared plus 5. No need to put absolute value because it is for any x value it is going to be positive. So this is the first technique of substitution. It's not exactly substitution. I didn't make any substitution. But what it is very helpful is that sometimes these kind of steps are like, you can just make a quick math and saves a lot of time. Now, if I give the same example, let's say if I got, let's say, only just not 2 here, if I just got, let's say, x over x squared plus 5. So where you don't see the exact derivative in numerator. So in that case, what you can just do, you can just multiply and divide by the same number outside in order to keep the expression neutral. And you can see now the answer is ln x squared plus 5, because if you look at the derivative x squared plus 5, it is 2x, which is the exact answer. And this is how you do this kind of questions. One of the more other example that I can give is that, let's see if I have got x cubed plus 7x here, and we got 3x squared plus 7. Now you can see that the exact derivative of the denominator is in the numerator. So this answer is straight away ln x cubed plus 7x plus c. Another example I can give of the similar type is that if you have got to integrate tan x, if you're integrating the tan x expression, which is one of the very important one for HL. But since this is a substitution technique, this can be assessed even in SL. So what you get is, let's say, tan x can be written as sin x over cos x. Now, I have got a function in denominator. So let's say I have, I'm just going to just rewrite this expression, f dash x over fx is ln fx. So I have got a function in denominator and its derivative is in numerator. Now you can see that derivative cos x actually is negative sin x. But since I got only sin x, I can just attach a minus here and minus here, because then it is coming back to the neutral positive sign. So now you get a proper value that you can say negative. Cos x is negative sine. So the answer for this derivative is negative of ln cos x plus c. And if you bring this negative up here, so it can be written as ln of 1 over cos x plus c, according to the log properties. So this is the first type of question that is very handy to when you get the questions on substitution. Now, what kind of questions that we get here is that how and what should be our technique of substitution. So now when you have got like a question like this, now how do we figure out that, okay, we got to go by substitution technique. Now, what you got to understand is that the substitution that you're making. Now, let's say I'm thinking of making, let's say here, entire sine x raised to 4 substitution. Now, what I should think of is that if I'm substituting, let's say, sine expression, now forget about this. Now, do you have at least the derivative of sine x raised to 4? Now, I don't have the derivative of sine x raised to 4, so thinking about that substitution is actually wrong. So what I'm going to do is, let's say now here, is there anything I can substitute whose derivative, at least the variable, if not the constant? Probably I can start with the first number here. So let's say here, if I look at, let's say x square. Now, when I substitute for x square, its derivative is 2x. That is multiplied along with the given function. So what I look at is this as a strategy is that any substitution you're making. So let's say gx is a function and f of x is a function. Now, in this g of x, any substitution that you're making and which whose derivative is, if not exact derivative, at least f of x has the variable, that variable derivative. Now, for example, x square, I have got 2x. Now, if you even though there was no 2 here, you could have done the substitution as let some variable be equals to x squared. So similarly, if I have got, let's say, x raised to 4 here, if I make the substitution x raised to 4, the derivative of x raised to 4 is actually 4x cubed. So that's this part here. Now, even though I don't have 4, I would go for substitution with x raised to 4 because at least its derivative is it's a multiplier here. Now, same way here. Now, if I make a substitution of ln x, the derivative of ln x is 1 over x, which is as a multiplier here. Here also, if I look at derivative of this fragment, 7x raised to 6 plus 8, I have at least x raised to 5 as a multiplier in numerator. Here also, x squared plus 5, at least I've got 2x as the derivative. So let's just begin up with the first question that is B here. And let's see how do we proceed for doing the questions on integration or substitution. So let's say if I've got 2x e to the power x squared dx here. Now what I'm going to do is that I'm going to take, let's say, u as x squared. Okay, I took a u as x squared because if I could get something like e raised to u, then it makes so much sense and it can just give us the something integratable stuff. Now, remember that whenever you're making a substitution, then in that case, your answer should be basically giving you, your answer should be coming to a simpler version of the expression, not the complicated one. So let's see how do we get now from here onwards. So you're going to find out, you're going to replace this dx now in terms of du. So you differentiate this, du by dx is 2x. Now what you do is you can just make the dx the subject here. Dx, if I make the subject, I get du over 2x, and I can replace out here. So let's see what do we get. So 2x times e to the power u times du over 2x. Now as a result of this get cancelled. So we get integration of e to the power u du. So e to the power u integration is nothing but e to the power u itself plus c. So the final answer is e to the power x squared plus c. Now this is the first example where I would summarize the step. So first make the substitution. You make u substitution. Replace dx in terms of du. Once you get this, then you integrate and substitute back. So these are the 4 steps you can summarize in. And let's take the next example now. So now in the second example, when you look at basically, in this case, what you're finding out is that let's say sine x to the power 4x cubed. Now here the substitution that you look forward to do is that, okay, if I take x to the power 4, at least its derivative is there here. Now similarly, like what I do is now I go ahead with the next step is that, okay, once I figure out the substitution that I need to do, so let's say sine x raised to 4 dx here. Now let's take u as x to the power 4. Now my next step is to replace this dx in terms of du, because now my integration expression will be in terms of u. So du by dx is 4x cubed. Now this expression 4x cubed that I got here, now I'm going to express dx the subject. So du over 4x cubed I'm going to get. Replace this out here. So what you get is, as a result, x cubed sine u times du over 4x cubed. Now x cubed and x cubed get cancelled, and 1/4 of sine u du. Now 1/4 of sine u integration is negative 1/4 of cos u plus c. Now then you put back the expression that you took in the beginning. So negative 1/4 of cos x to the power 4 plus c. So this is the expression that this is the way that you can integrate this given expression. Now let's take one more example. So let's just take the example f now. So when you're talking about the example f, the first thing comes to your mind is what substitution do you make? Now, always remember the substitution that you should make, at least its variable should be there as a multiplier, like how we had here, these stuffs. Now, for example, ln x, if I take here, so it is 1 over x. So same way, if I look at this example, now if I take entire thing, let's say u as 7x to the power 6 plus 8. Now, if you look at the derivative of this, now du by dx is basically 42x to the power 5. Now, even though if I don't have x 42 here, that's okay. So what we can do is now you can either make dx a subject, or what you can do is, if you just want to get rid of this x to the power 5, so what you do is dx is du over 42x to the power 5. So at the end, what we get is x to the power 5 over u to the power 20 times du over 4x to the power 5. This and this get cancelled. So what we get is at the end 1/4 of du over u to the power 20. Now if I integrate this, 1/4 is going to be u to the power negative 20 here. And if I integrate this further, it'll be 1/4 u to the power negative 19 over negative 19 plus c. So it is 1 over 4 times negative 19 u to the power 19. Obviously, you can simplify this. Plus c. So u is nothing but, now you can plug back 7x to the power 6 plus 8 to the power 19, and this answer is as it is here. So this is the integration of this particular part. So in this example, what we do is we take just now. See, the thing is that when you make the substitution here, the intuition is that okay, you want to make for the entire expression ln x the whole square. But what you do is, because since you have just got 1 over x as a multiplier, that is indicator that you take the substitution as basically, let's say I have to integrate ln x the whole square over x. So let u be ln x basically. Now here, once again, you do the similar procedure. Du by dx is going to be 1 over x. So du is going to be, if I make du will be 1. So here du by dx is, yeah. So dx, if I make the subject here, so x du will be equals to dx. And in place of dx, if I plug x du, so what we get is u square or x times x du. This get cancelled. So what we get is integration of u square du. Now when you integrate u square, what we get is u to the power 3 over 3 plus c. So the final answer is ln x the whole cube over 3 plus c. So that's how you do the integration substitution by basic methods.